Hi friends, are you ready to learn something about buffers? But not yet, I'm afraid. Wait another 5 minutes, okay? No, only joking. Of course we'll start now. Buffers go hand in hand with acids and bases. So if you really have no idea what an acid is exactly, then first of all, check out our video on that. So, what exactly do these buffers do? In simple words, buffers are used to keep the pH of a substance as stable as possible. Imagine a liter of water. If we throw in 0.1 moles of hydrochloric acid and wait, the pH will change significantly. If you want to know exactly how much, the pH of the water will drop from 7 to 1. But now if we had added a buffer, the pH would barely change. The buffer ensures that the pH of a substance remains as stable as possible. Now that sounds pretty cool in theory, but how exactly does a buffer do that? Doesn't that scream out for an example? A great example would be the so-called acetic acid acetate buffer. This buffer simply consists of acetic acid and acetate ions together. But you have the same amount of both in a 1:1 ratio. So we set up the protolysis equilibrium. That looks something like this. Acetic acid and water simply stay in equilibrium with the acetate ions and oxonium ions. Now, let's look at the effect of the buffer on this equation. If we add an acid, the concentration of oxonium ions increases. Now we have more H3O plus ions. The reverse reaction becomes stronger. Acetate ions also react with H3O plus to make acetic acid and water. So the concentration of H3O plus goes back down and the pH goes back to the same level it was before adding the acid. If we add a base, the concentration of hydroxide ions will increase. So now the forward reaction of acetic acid and hydroxide ions forming acetate and water becomes stronger. And that goes on until the concentration of hydroxide ions is reduced to around the same level as it was in the beginning. And that's the whole story about buffers. Let's summarize everything quickly. We use buffers to keep the pH of substances as stable as possible. For example, if we add an acid, the reaction in the direction which brings the concentration back down will become faster. And so, a substance can be relatively stable against fluctuations in pH. So far so good. Now we've got the explanation, we only need the practice. There's nothing like going over the exercises, so we'll see you there.